Okay, so it's already 5. I'll start the class now. Good evening, everyone. This is the second live discussion session of the course Geotechnical Engineering 1. The topic of this session is week 2. The topic is basic relationships, index properties of aggregates. In the last session, I have discussed about the origin of soils and rock cycle. Those who have joined the session, they have taken down the notes, the question answers, and I think the solved PPT has been shared with you, and the video link of the YouTube has also been shared. So, like the previous session, this class also has a combination of multiple choice questions, true false statements, and a few numericals. Okay, so I'll first start dictating the questions. So all of you need to write down the questions as I dictate, and I'll give you time to write down the questions and the options. After that, I'll give you some time, generally 10-15 minutes time I'll give you to solve those questions. And after that time, I will start discussing the solutions and explain them individually. Okay, so those who might have solved the questions, they can answer and explain to make the session more interactive. Otherwise, I'm going to explain those answers anyway. Okay, so I'll start with the questions now. Yes. So if I am like inaudible and there is a glitch, okay, please raise your hand and try to raise an issue for that. Okay. All right. So I'll start with the problem solving sessions of week 2 of the course Geotechnical Engineering 1. The topic is basic relationships, index properties of aggregates. Just a moment. So the first question is, please write down the questions first, okay? Don't discuss the answers in the beginning. Yes. What is degree of saturation? What is degree of saturation? Your options are moisture content of soil mass in its natural state. Option 2, ratio of volume of water in a soil mass to the volume of soil solids. Option 3, ratio of volume of water in a soil mass to the total volume of voids in it. And option 4, moisture content of soil mass in its saturated state.
I think option C.
As I have mentioned, don't discuss the solutions now. Please write
Okay.
down the questions and solve them individually. Okay, you should solve them on your own. So I'll give you time to solve these questions. After which I'll start again this same meeting. Okay, I will start discussing the solutions. Okay, at that time you can tell me the answers. Okay. I repeat once again, what is degree of saturation? The options are moisture content of soil mass in its saturated state, ratio of volume of water in a soil mass to the volume of soil solids, Ratio of volume of water in a soil mass to the total volume of voids in it. And the last option is moisture content of soil mass in its saturated state. I hope it's clear. I'll go to the next question. Yes. Relative ease with which a soil mass can be deformed is termed as. The relative ease with which a soil mass can be deformed is termed as. Your options are toughness, compressibility, consistency, or sensitivity. I repeat, relative ease with which a soil mass can be deformed is termed as. The options are toughness, compressibility, consistency, or sensitivity. Okay, next question. The term density index is not applicable to cohesive soils because the term density index is not applicable to cohesive soils because the options are it is difficult to obtain particle size gradation. Option 2, uncertainties in determining the void ratio in the natural state. Option 3, uncertainties in determining void ratio in the loosest state. Option 4, uncertainties in determining void ratio in the densest state. I repeat the question. The term density index is not applicable to cohesive soils because it is difficult to obtain particle size gradation, uncertainties in determining void ratio in the natural state, uncertainties in determining void ratio in the loosest state, uncertainties in determining void ratio in the densest state. I hope it was clear. Next question. Percentage voids is another term for. Percentage voids is another term for. The options are percentage air voids, void ratio, degree of saturation, or porosity. I repeat the question. Percentage voids is another term for. The options are percentage air voids, void ratio, degree of saturation, or porosity. Okay. Next question. Coefficient of uniformity is a measure of. Coefficient of uniformity is a measure of. The options are shape of the particle size distribution curve, percentage of fines in any soil mass, plasticity index, or particle size range. I repeat the question. Coefficient of uniformity is a measure of. The options are shape of the particle size distribution curve, percentage of fines in any soil mass, plasticity index, or particle size range. Okay. Next question. The maximum water content at which a reduction in water content will not cause a decrease in the volume of soil mass. The options are liquid limit, shrinkage limit, plasticity index, or plastic limit. I repeat the question. The maximum water content at which a reduction in water content will not cause a decrease in the volume of soil mass. The options are liquid limit, shrinkage limit, plasticity index, or plastic limit. Someone has joined now. Please write down the questions as I dictate from the current one. I'll give you time to solve them and then I'll discuss these questions one by one. Okay. Okay. So the current question is the maximum water content at which a reduction in water content will not cause a decrease in the volume of soil mass. And the options are liquid limit, shrinkage limit, plasticity index, or plastic limit. Okay, just a moment.
Sir, good evening, sir.
Yes, yes. Good evening.
Can you make it to full mode, sir?
Which mode? Full mode.
Full mode.
No, actually, I have to toggle between the recording software, the Google Meet, and this
Okay.
PowerPoint. Okay,
Okay,
so
okay,
I
okay,
I
sir.
can just make it a bit bigger, but that's all I can do. Okay,
It's okay, sir. It's okay, sir. No problem.
okay. Just a moment. Okay. Yes. So the last question was, sorry for the disturbance. The last question was the maximum water content at which a reduction in water content will not cause a decrease in the volume of soil mass. And the options were liquid limit, shrinkage limit, plasticity index, and plastic limit. Okay. Next question. Addition of consistency index and liquidity index yields a value of. Addition of consistency index and liquidity index yields a value of. The options are 0, 4, 1, or 2. Someone has their microphone on. Please mute yourself. Yeah, thanks. I repeat the question. Addition of consistency index and liquidity index yields a value of. The options are 0, 4, 1, or 2. Okay, next question. When the percentage voids is 34, what is the void ratio of the soil? When the percentage voids is 34 percentage, what is the void ratio of the soil? The options are 0.623, 1.204, 0.515, or none of these.
Sir, slide number 10 and question number 10 both are same or different?
Slide number 10 is your question number 9 because the first slide is
Okay.
not a question. It is
Okay,
the,
fine, sir.
yes,
Fine.
this is question number 9. Okay.
Okay, sir.
And just a moment. It is question number 8 because I have skipped one slide which has the a solution to a question. Okay. So this is question number 8. Clear? They were asked.
Yes, sir, it's clear.
Yeah.
It's clear.
Okay. So I repeat the question. When the percentage voids is 34 percentage, what is the void ratio of the soil? The options are 0.623, 1.204, 0.515, or none of these. Okay, next question. So this is a true or false statement. A soil is said to be uniformly graded when it has a good representation of particles of all sizes. Is this statement true or false? I repeat, a soil is said to be uniformly graded when it has a good representation, sorry, a good representation of particles of all sizes. Is this statement true or false? Next question. Yes. The Casagrandes apparatus is used for determination of. The Casagrandes apparatus is used for determination of. Your options are liquid limit, shrinkage limit, consistency index, or plastic limit. I repeat the question. The Casagrandes apparatus is used for determination of. The options are liquid limit, shrinkage limit, consistency index, or plastic limit. I hope you have ideas about these terms: liquid limit, shrinkage limit, consistency index, and plastic limit. You are familiar with these terms, right?
Yes, sir.
Okay, so what is consistency index?
Consistency index is a liquid limit minus NM's natural moisture content divided by plasticity index.
Very good. And what does it determine? Like, what does it signify? A high value of consistency index and low value of consistency index. What will that signify? If the consistency index is high, what will the what will the implication on the soil? Good soil, bad soil, strong or weak soil?
It gives some nearness of the natural moisture contents to the uh, something like a plastic limit. I would say.
No, the consistency index, if it is high, then what can be
Okay,
said about the soil? Like, is it a good soil? Is it a weak soil? Is it a good for foundation or something like that? Construction purposes. What can be said? Any
it
idea?
is a weak soil. It is a weak soil, sir. High moisture content.
Consistency index will be high, so it's a weak soil.
Yes, sir.
No, consistency index is
One
equal.
one second, sir. 1 second. Liquid limit minus
It's
NMC
Yeah, it's
by
okay. It's
IP.
okay. You take your time. You take your time. Let me discuss the questions first. It was just an off track, question.
Okay,
So you
okay.
have heard about these terms, right? You know
Sure,
what
sir.
what the definitions are. Okay, fine. When I give you time to solve this, okay, then look into it and find the definition, and then you can tell me. Okay, no worries. Yeah. So next question. Yes, a soil mass compacted at a moisture content of 12 percentage has a bulk unit weight of 18.73 kilonewton per meter square. Please mute yourself. Somebody is has left microphone on. Has a bulk unit weight of 18.73 kilonewton per meter cube. Its dry unit weight in kilonewton per meter cube is, the options are 15.98, 21.34, 15.87, or 16.72. I repeat the question. A soil mass compacted at a moisture content of 12 percentage has a bulk unit weight of 18.73 kilonewton per meter cube. Its dry unit weight in kilonewton per meter cube is, the options are 15.98, 21.34, 15.87, or 16.72. Okay, next question. Okay, this I think is the second true or false statement. A temperature of 105 to 110 degrees centigrade needs to be maintained for oven drying. Please ignore the spelling. This oven drying, yeah. For oven drying method of water content determination, is this statement true or false? And you have to give some justification. Okay, not like just merely stating true or false will do over here, because this is a interactive session. So whatever your answer is, you should be able to give some justification. Okay, if it is false, then what is the correct statement? What is the correct temperature? Okay, if it is true, then why it is true? Why that range? Okay, As I have mentioned, please do not discuss the answers right now. Let everyone solve, and you also solve these questions. I'll give you time to solve the questions, after which I'll start the discussion. At that time, I'll ask you, those of you who know the answer, they can tell me the answers with the proper explanation. And if you can't, you know, solve these questions, then also there is no issue. I'll be solving them and giving the explanation anyway. Okay. Please don't discuss or ping the answers right now. Let everyone solve. Okay. So the question was, it's a statement. Basically, a temperature of 105 to 110 degrees centigrade needs to be maintained for oven drying method of water content determination. Okay. So this statement is true or false, you have to say. Okay. Next question. Flow index is, first option, measure of particle flow after complete saturation. Option 2, degree of stiffness after reduction in moisture content. Option 3, slope of the flow curve in liquid limit test. Option 4, difference between liquid limit and plastic limit. I repeat the question. Flow index is, option 1, measure of particle flow after complete saturation. Option 2, degree of stiffness after reduction in moisture content. Option 3, slope of the flow curve in liquid limit test. Option 4, difference between liquid limit and plastic limit. I hope it was clear. This is basically the definition of flow index. You have to say which option is correct, is the correct definition of flow index. Okay, next question. In a wet soil mass, air occupies one-sixth of its volume and water occupies one-third of its volume. The void ratio of the soil is, the options are 0.25, 1, 0.5 or 1.25. Someone has joined now. Please write down the questions first from the current one. I'll give you time to solve them later. I repeat the question. In a wet soil mass, air occupies one-sixth of its volume and water occupies one-third of its volume. The void ratio of the soil is, the options are 0.25, 1, 0.5, 1.25. Okay, next question. A soil deposit has a void ratio of 1. If the void ratio is reduced to 0.6 by compaction, the percentage loss in volume is, the options are 10, 20, 30 or 40. I repeat the question. A soil deposit has a void ratio of 1. If the void ratio is reduced to 0.6 by compaction, the percentage loss in volume is, the options are 10, 20, 30 or 40. Next question. Yes. Which of the following is constant for a given soil? Which of the following is constant for a given soil? The options are bulk unit weight of solids, dry unit weight, or saturated unit weight. I repeat, which of the following is constant for a given soil? Bulk unit weight of solids, dry unit weight, or saturated unit weight. Next question. Find the porosity of a soil whose void ratio is 0.5. Find the porosity of a soil whose void ratio is 0.5. The options are 0.5, 1, 1.333, 0.333. I repeat, find the porosity of a soil whose void ratio is 0.5. The options are 0.5, 1, 1.333 or 0.333. Okay. Next question. For a soil in natural state, void ratio is 1, water content is 30% and specific gravity is 2.5. The degree of saturation in percentage is, the options are 0, 100, 40 or 75. Just a moment. This was the current question, right? The degree of saturation.
Yes, sir. This is the correct question.
Yes, yes, okay. Yes, for a soil in natural state, void ratio is 1, water content is 30%, and specific gravity is 2.5. The degree of saturation in percentage is, the options are 0, 100, 40 or 75. Okay, next question. Theoretically, the void ratio in soils can have the following values. Very simple question. The options are more than 1, can be less than or more than 1, less than 0.5, less than 1 only. I repeat, theoretically, the void ratio in soils can have the following values. More than 1, can be less than or more than 1, less than 0.5, less than 1 only.
Sir,
Yes,
why you added theoretically, sir? If you remove that, the answers remain same, right?
the answers remain same, but depending upon which option is correct. Practically, whether,
Yeah, understood, sir. But
yes,
if you remove the theoretically word, does will the answers or questions will match or not properly? Answer and
yes, that
question.
is the thing. The options that is correct over here. Okay,
Okay, okay, okay,
that
okay.
is correct over here. Practically, it will be kind of difficult to find that soils in natural state. Okay, if you are
Yes, sir.
taking a soil sample in any confined system in the lab,
Hmm.
okay, that's a different thing.
Yes.
But I'm telling theoretically because in natural state, that kind of scenario might be difficult to find. Okay, or
Yeah,
it is rare.
I will discuss, sir. After some time, I will discuss.
Yes, yes, okay.
Yeah, because what happens is there was another lecture last semester by Dr. Dilip Kumar Vaidya, IIT Kharagpur.
Yes, yes,
In his lecture notes, theoretically what he used and then he mentioned the value, it can be 0 to infinite. That is not theoretically it is possible, practically it is not possible.
yes, yes, exactly.
That is the meaning of theoretically. That's why
Yes.
I'm.
Theoretically, here also the answer is possible, but practically, I will not say it is impossible, but it is very rare or difficult to find. Okay, that's why I went theoretically.
Okay, sir. Thank you.
Yeah. Next question. A soil sample of mass 0.18 kg having a volume of 10 to the power minus 4 meter cube is mixed with 0.02 kgs of water. Its dry density is 1600 kg per meter cube. The initial and final water content in percentage is. So if you're having problem in writing the entire thing or it's taking time, just write down the data like mass is 0.1 kg, volume is this much, additional water is 0.02 kg, dry density is this, initial moisture content and final moisture content must need to find over here. The options are 10, 20, 12.5, 25, 2.5 and 5 or 15 and 30. I repeat the question. A soil sample of mass 0.18 kg having a volume of 10 to the power minus 4 meter cube is mixed with 0.02 kgs of water. Its dry density is 1600 kg per meter cube. The initial and final water content in percentage is 10, 20, 12.5, 25, 2.55 or 15, 30. Okay. Next question. A particle size distribution curve with a flat portion represents. The options are uniformly graded soil, well graded soil, gap graded soil, or poorly graded soil. I repeat the question. A particle size distribution curve with a flat portion represents uniformly graded soil, well graded soil, gap graded soil, or poorly graded soil. Okay. The last question. Write down this question very carefully. A cube of dried clay having sides 5 centimeter long weighs 135 gram. The same cube of soil, when saturated at unchanged volume, weighs 195 gram. The specific gravity of the soil is, the options are 2.652, 1.968, 2.067, 2.077. The first part of the question, you're supposed to find out the specific gravity of the soil, where the dimensions of the cube of dried clay have been given. The sides are 5 centimeter long. The weight has been given 135 gram. The same cube, when it is saturated at unchanged volume, it weighs 195 gram. So to find out the specific gravity of the soil, and then the second part of the same question, you have to find out the void ratio of the soil. To find out the void ratio of the soil. Okay. So I hope you have written down the questions. So how much time do you need? Because I think I can give you 10 to 15 minutes maximum. Someone is joining right now. Okay. So I'll start at 7:05. Will that be okay? Discussing the solutions. I'll give you some time like 8 plus 5, 13 minutes. I'll give you. Will that be okay to solve these questions? Yes.
Yes, sir.
Okay, fine.
Sir, can you show the first one or two slides?
Okay, first like okay, the first question was what is the degree of saturation? You have to just write down the definition. If you know, you can write down. No need to
Okay.
copy the options. The second question was relative ease with which a soil mass can be deformed. What is the term used for it? Toughness, compressibility, consistency, or sensitivity. Okay. The third question was density index is not applicable to cohesive soils because it can be difficult to obtain the particle size gradation, or there are uncertainties in the three options. Uncertainties in determining the void ratio in natural state. In the third option, the same for the loosest state. In the fourth option, the same for the densest state. Why density index cannot be applied to cohesive soils? In the fourth question, percentage voids is another term for which term over here? Percentage air voids, void ratio, degree of saturation, or porosity. Percentage voids it's an percentage voids is another term for which among these? Okay. And the fifth question was coefficient of uniformity is a measure of what? Shape of the particle size distribution curve, percentage of fines in any soil mass, plasticity index, or particle size range. Okay. So I will leave it
It's
there.
enough, sir.
Okay.
Yeah, yeah.
Please solve these questions. I'll start around 7:05 or 7:06. Okay.
Okay, sir.
Yeah, sorry for the inconvenience. The timing will be 6:05 or 6:06. Actually, the classes is scheduled from 6 to 8 on Fridays, but today it is from 5 to 7. So it was a slip of tongue. I apologize for that. It will be, I'll start the session at 6:06. Okay. I hope you have completed the solutions. Have you completed solving the questions? Am I audible?
Yes, sir, you are audible.
Okay. So I will now start discussing the solutions one by one. Okay. So the first question was, what is degree of saturation? What is degree of saturation? Any answer? Anyone
So
has any
third one,
answer? Third one, ratio of volume of water in a soil mass to the total volume of
you have voids in it.
voids in it. Yes. Someone is saying 4, moisture content of soil mass in its saturated state. It is not the correct answer. Option 3 is the correct answer, ratio of volume of water in a soil mass to total volume of voids in it. That is, degree of saturation S will be defined as volume of water divided by total volume of voids. How much of the void volume is filled up with water? That is the degree of saturation in percentage. Okay. So ratio of volume of water in a soil mass to the total volume of voids in it. It is
Sir,
called
are
as.
you giving answers?
Yes, I'm giving the answers. Who was that? ARP. Yes, I have started the solutions. Okay. Yes, so the first question, the answer is option 3, ratio of volume of water in a soil mass to the total volume of voids in it. Okay. Second question, relative ease with which a soil mass can be deformed is termed as. What is the answer? Yes,
Consistency.
consistency. Very good. Consistency is defined as the relative ease with which a soil mass can be deformed. Then what is toughness? What do you mean by toughness? Toughness is defined as the resistance to impact load. Okay. Generally, soil or aggregate, when impact loading test is performed for checking their suitability as subgrade, then their resistance to impact load is termed as toughness. What is compressibility?
Ability of material to deform when you apply compressive loads.
Yes, but deform means there is a reduction in volume,
Yes, sir.
isn't it? Specifically, when we say deformation in during
Vertical.
compressibility, like there is compaction and consolidation, the thing that happens is because of the externally applied force, there is a reduction in volume. Okay. What is sensitivity?
Reduction in the strength of the soil due to remolding.
Yes, degree of disturbance due to remolding. Degree of disturbance, okay, reduction in strength or not, it is a specific case, but sensitivity means how much affected is the soil upon remolding. It is sensitivity. Okay. So it is in general sense that I'm asking, it is the answer is okay. Relative is with which a soil mass can be deformed is termed as consistency. Yes. Next question.
Sir, can I see the previous question, sir, once?
Oh, previous question. Okay. Yes. The third option is the right option.
Sir, I think there was a mistake. I think as per my knowledge,
Yes.
what is the denominator in the third option, sir?
Total volume of voids.
But the degree of saturation is it's a ratio of VW to the VV, not total V.
Total volume of voids.
Okay, whites you have mentioned. Fine,
Yes,
sir.
yes.
Fine,
Total
fine.
volume of
Then it's
voids.
okay, sir. Thank you.
Yes, yes. So the first two questions are done. Now the second question, sorry, the third question. The term density index. Just a moment. Yes. The term density index is not applicable to cohesive soil. Why? Why it can't be applied to cohesive soils? Any answer? Okay. So the answer is option 3. Okay, before that, I'll just give the definition. What is the term density index? How can you define density index? E
E
max,
max minus E upon
E upon, yes, tell me, E max minus E min,
E
right?
max minus E minimum.
E minimum. Now what happens is E max, it is the maximum void ratio. That means it is in the loosest state. So for cohesive soil, because of their inherent cohesion, this E max is very difficult to find out. And even if you can find out, there are high level of uncertainty associated with this value E max. So this term is not applicable for cohesive soils. And Emax means void ratio in the loosest state, right? So third option is the right option.
Other two, can you determine, sir? Natural and minimum state, minimum wide ratio, we can determine per place.
Natural we can determine using the density, using the what
Core
that
cutter
is
or
index properties, basic index properties formula, and
yeah.
minimum means it is the densest state. So once we have obtained theoretically in the laboratory the maximum level of compaction in a suppose in a clay soil, okay, we say that it has been compacted, okay, maximum dry density corresponding to the optimum moisture content, then that can correspond to the E minimum. Okay, that can correspond, but doesn't matter how much we add water or how much we break the soil so that it can have large number of voids. What is the maximum value of you know uh, void ratio? And apart from that because these cohesive soils have inherent cohesion between the particles, that makes it harder to determine the void ratio in the loosest state. Okay, so other two can be determined, even if not with 100% certainty, but this one has the maximum level of uncertainty for cohesive soil. Okay, hence it is not applicable, this term is not applicable for cohesive soils. Okay. Okay, next question. Yes, percentage voids, what is the answer?
Porosity.
Porosity, yes. Percentage voids is porosity, VV, volume of voids by total volume into 100. Degree of saturation, I think I've said earlier, void ratio, volume of voids by volume of soil solids, and percentage air voids, volume of air divided by total volume. Okay, so percentage voids is another term for porosity. Clear? Yes,
Yes,
next
sir.
question. Coefficient of uniformity is a measure of. Coefficient of uniformity is a measure of. What is the answer?
Sir. D, option D.
Option D, yes, particle size range. Then what is the term for the first, option?
CC.
CC, coefficient of curvature. The formula is D30 whole square divided by D60 into D10, right? And this is coefficient of uniformity is D60 divided by D10. Particle size such that 10% of particles are finer than this size, and D60 is particle size such that 60% of particles are finer than this size. Anyway, this Cu determines the particle size range. Okay. Okay, next question. The maximum water content at which reduction in water content will not cause a decrease in the volume of soil mass. What is the answer? This is easy. Yes, tell me.
Shrinkage limits.
Yes, shrinkage limit. Shrinkage limit. This diagram you can see on the abscissa x-axis we have the moisture content. On the ordinate we have the volume, total volume of the soil mass. Now from A to B, from the right towards the left, A to B and then C, you can see that reduction in water content is causing a reduction in volume up till B, and then from B to C, even we are decreasing the moisture, then also the volume is not decreasing, and that particular moisture content at B, here signified with WS, is called shrinkage limit. Okay.
Sir,
Yes.
this graph originally they found out by only for dry cycle, no, sir. It's not for wet cycle.
No, dry cycle means wet cycle.
That means when you dry the soil, when a wet soil is dried,
Hmm.
then these observations will be made actually. But can you call this one when you wet it? Wet it means that when the water content is increasing.
Yes. When the water
This
content is
is
increasing, see over here VD is the volume of dry soil. Okay. First we are adding water and then up to this level there is no increment in volume. There is no increment in volume. Okay. Now after
yes,
that the volume start increasing. That means water is starting to take up the extra space. The soil is there. Water starts taking up the extra space and so the volume is increasing. This is the volume of water increasing. This is the volume of dry soil basically. Okay, in solid state. This is the volume of dry soil. Now as the water starts increasing, obviously if on reduction of water the states they change, on addition of water also the same states will follow, isn't it? You add
yes, sir.
water, it will first be in a semi-solid state, then be in a plastic state, and if you go on adding more and more water, it moves beyond the liquid limit, it goes to a liquid state, isn't it? So
Yes,
it
sir.
is the same for drying and wetting cycle. You can start at A till C when you are drying the soil, and then start at C towards A when you are adding water to the soil. Okay. So
But
basically,
did they observe that, sir? Actually,
yes, it has been obviously observed because see, if any changes during the wetting cycle as you are talking about, then in this graph there would have been another line like this, something like this. We find that in many graphs where the reversible change shows some different phenomena. In chemistry also we have seen in physics everywhere. It's not like in every phenomena will give the same what to say observation during forward and backward reactions, right? So here
yes,
also
sir.
if there was something observed previously by researchers, that would have been in the same graph only. But as per the research and as per the engineering and scientific scenarios, when we add water to soil, it can be any kind of soil. Obviously, it is written over here. So these are the states that you know has been observed for a soil upon addition of water and upon the reduction of water. Okay.
Yes, sir. Yes, sir. I understood. But what happens is in most of the books,
Hmm.
I saw only The graph is applicable for both cycle wetting and drying,
Yes,
but they don't
because
mention in a wetting actually books.
yes, because they don't mention the wetting, because this point, the definition of shrinkage limit, there is no decrease in volume of soil mass. There is no
Hmm.
decrease in volume of soil mass. This observation is specific. Okay. See, the increment in the volume is from here to here. Okay. But the decrement is
It,
from here to here. So which part will be more specifically, correctly observed? This part, right? Because here we can, our focus might get diverted in any of this section. Okay. So the smaller the range,
yes,
the more we can focus. Here we are going on adding water. Some people are taking observations over here and then over here. Okay, the volume is now changing. Okay, the volume stops changing. It is here, but this part is, you know, having more volume of water, so that the last stage is being reached. So in that aspect, I think it is better if you say in the drying cycle and not in the wetting cycle. Okay.
and my observation, sir, my
Yes.
observation here is normally these tests, all these consistency limits are tested with the help of oven, particularly shrinkage limit is with the help of oven.
Yes. Yes.
In oven, initially we are going to keep the saturated specimen.
Yes.
Then as the time passes, 1 hour, 2 hour, 3 hour, 4 hour, as time passes, water content is reducing. That's why normally they go for towards the y-axis. Water content is
Yes,
reducing
the
towards.
test normally goes towards the y-axis, but what you have said, the definition in one, I think, I don't know, it was a foreign author's book or not, the definition of shrinkage limit was itself reversed,
Mhm.
The moisture content, beyond which the volume starts changing, volume starts incrementing. Okay,
Okay.
so you can tell it in
Yeah,
any way. It is, some people have made this in this way, so we are now following, because it is the normal textbook, scenario. So
fine, sir.
maybe
Thank you.
someone will modify it as per his own research later. Okay.
Yes,
Okay,
sir.
so I hope this is clear, the definition of shrinkage limit. Next question was, one second, yes, addition of consistency and liquidity index yields a value of, what is the answer?
It is one, sir.
How? What is the
You
formula?
can add. You can add the
Yes,
one
it's
is
just the
liquid
simple
limit.
formula. And you were saying one thing, like consistency index is more, the soil is weak, right?
No, 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 sir. It's my mistake. It is my
Yes,
mistake.
yes, yes.
It is actually in dry state.
Yes, the
It is
moisture
more.
content is less. The soil will
It-
be good for
yeah, yeah.
foundations and other purposes. So
It's
this
my
is the
mistake.
formula for, it's okay. This is the formula for consistency index and liquidity index, and this is W minus WP, right? Plastic limit by IP. If you add those, we'll get IP by IP, that is equals to 1. Okay. So going by
Yes.
the basic definition, we can get a value of 1. Okay. Next question is, just a moment. Yes. When the percentage voids is 34%, what is percentage voids?
Porosity.
Porosity. Percentage voids is porosity. It is 34%, means 0.34, isn't it? 0.34 in terms of decimals. Now, what is the value of void ratio with respect to porosity? E equals to porosity divided by 1 minus porosity. What is the answer you're getting?
Point 5.
0.515, right? Third
C.
option. Yes, yes. Third option is the correct
Yes.
one,
Yes, sir. Yes, sir.
0.515. Okay, simple formula. Now the next question is, a soil is said to be uniformly graded. It has good representation of particles of all sizes. What is the answer? True or false? True or false?
False.
Also,
Yes, false. Why? Then why it is, what is it called? It has a good
it's a narrow
representation.
range.
No, when the soil has a good representation of
Good
particles.
representation. It is well graded, sir.
Yes, well graded soil. It is a well graded soil. Okay, uniformly graded means it has more particles of one particular size. Okay, so there the interlocking is not proper. Okay, next question. The Cassagranes apparatus used for
Liquid
Liquid
limit.
limit.
liquid limit test. Yes. Next question. The numerical, the soil mass compacted at a moisture content of 12%, bulk unit with this one, dry unit weight. What is the answer?
Option D, sir.
Option D, yes. The formula is dry unit weight equals to total or bulk unit weight divided by 1 plus moisture content W, isn't it? W is 0.12, gamma is 18.73, bulk unit weight. So dry unit weight is 16.72. Yes, good. Yes, hello, someone is speaking. Okay, if you have finished, saying the answer, you can mute yourself. Okay, next question is a temperature of 105 to 110 degree needs to be maintained for oven drying method of water content dissemination. What is the answer?
True, sir.
True. Why it is true?
Most of the pore water or free water can be eliminated with this minimum temperature.
Yes. And why it
Boiling point
can't
of
go?
water is
Why it can't
boiling
go
point of water is 105, 100 and 400 degrees centigrade.
100 degree? But if it is more than 105, then the time will be less because we have to keep it right. That's also an important factor during laboratory testing. Why it can't be more than 110?
There is no any difference in the moisture content, sir. Whatever you observe in the 110, it remains more or less same at the higher temperature
No,
also.
then I can say that I will keep the temperature of the oven to 120, and I'll get the dried sample faster.
It will affect the structural water.
Yes, that is the thing. It
Stru-
will affect the structural water. See,
But the structural water is higher temperature, no, sir. It is
no
above
structural.
1000 degrees, 500
No,
degrees.
there is. Okay, so it basically, see, for clay particles, for clay minerals. Okay, now when we are saying soil, okay, we know that there are different types of soil. There is fine graded, there is coarse grained soil, there is fine grained soil, there is clay, silt, sand, gravel. But in reality, you don't get one particular soil, right? If you go to a sea beach, you will get just sand. But in reality, any geotechnical structure, foundation, slope, do you think you will get only one particular type of soil? No. So if it is a mixture of some clay particles where there is clay minerals, then the crystalline structure of those minerals might get changed. It
At
might
this
cause
only 10 degrees centigrade difference, you have a
100.
crystalline structure will affect, sir.
If it is more than 110, it might affect for some clay minerals. So clay particles is there for some clay minerals. If it is more than 110, the crystalline structure might break, and then the chemically bonded structural water inside them, the compounds, that might get affected. Okay, so it is better to keep it less than 110 and more than 105. Yes, it affects. If it is more than 110, it affects the crystalline structure of the clay particles. Okay, so that's why this maximum limit have been specified. I hope it is clear. Yes. Next question. What is flow index?
See, sir.
Slope of the flow curve. Very good. So here we have the flow curve. Okay, here is the slope. So the value will be y2 minus y1 divided by x2 minus x1. What is y2? Now here it is reducing, so w1 will be more than w2, initial will be more. Okay, divided by log to the base 10. So here again n2 will be more than n1, n2 by n1 number of logs. Okay, so this is called the flow curve, flow index from the slope of the flow curve. Okay, next question. In a wet soil mass, air occupies 1/6 of the volume and water occupies 1/3 of its volume. The void ratio is, what is the answer?
B,
I
sir.
don't, B, that is 1, right? So air occupies 1/6, water occupies 1/3. So air and water, partially saturated soil. So the volume of voids will be volume of air plus volume of water. That is, I think it will come out to be V by 2. The volume
Yes,
of
sir.
void is V by 2. Volume of solids will be again V by 2. So what is void ratio? Void ratio is volume of voids divided by volume of soil solids. V by 2 gives us 1. Okay. Next question. Soil deposit has a void ratio of 1. Void ratio reduced to 0.6 by compaction. Percentage loss in volume. Any answer?
20%.
20%. How do you solve it?
Solids will be constant. Vs is equal to V by 1 plus E.
Vs equals to V by 1 plus E.
E.
So
That's a formula
V,
applied for both times.
yes, so V initial V1 will be 2 Vs, right? 2 Vs, void ratio 1, and V2 will be how much? V2 will be 1.6 Vs, right? 1.6. So change in V equals to 0.4 Vs. So change in V divided by original V by 100, percentage loss. So del V divided by V1 into 100. 0.4 by 2 into 100, right? So it is 20%. I hope it is clear. Next question. Which of the following is constant for a given soil? Which one? Constant.
Dry unit weight, sir.
Unit weight of solids.
The answer is unit weight of solids. Yes. The definition of this one is dry mass divided by volume of soil solids. Now, the definition of bulk unit weight. What is it? Mass by volume, simply. Definition of dry unit weight.
MS by
MS or MD, same thing.
both the same.
Yes, yes.
By V.
By dry unit weight, by V. Saturated unit weight,
M
mass
by
of
V.
saturated soil divided by total volume. You can see option 1, option 3, option 4 all has V as denominator. And V might,
Variable.
yes, V is a variable. V might increase or decrease depending upon compaction, external forces, addition of water. Only Vs is constant. For a given soil, if Vs is constant, this one is basically constant mass, and then this will be constant unit weight of soil solids. Okay, good.
Sir, small interaction here
Yes, yes, tell me.
with the permission of even other people.
Yes,
In the
yes.
question, you have mentioned, you have rightly said the question. Question is very nice.
Okay.
But at the last statement, for a
Yes.
given soil, if you remove, and
Hmm.
if you say for soils, given, if you remove the given word, and if you mention it is a soils, then it is also variable, na, sir?
For soils, okay.
Different
Given
soils,
soil,
it will
see,
be different.
for a this statement, for a given question, for a given solution, for a given soil, this is basically just a go-to phrase. you know,
Mhm.
the whoever makes the question, they use it. Now when I'm saying for a given soil, the problem is, see, basically, if this is a system,
Within the same soil you are discussing now.
in the same soil, yeah, if this is a
Yeah, yeah,
system
yeah.
and this is the, soil. So for this given soil, I mean for this given soil, you know, the volume of this given soil, the volume of this given soil, what is the V? What is V can you consider? I can take the entire thing as V, right? I can tell that this is the volume of the entire soil mass, and this is the, the soil being a three-phase system. I mean, this is a very simplified system. Suppose you have a container like this, top view. You have a container and you have soil like this. And the entire volume of the container you are saying to be the volume of the soil mass. Okay. So for this given soil, this total volume is depending upon the system which you are projecting the soil into. Okay. Now I take this soil, I put it onto a bigger container. I take this soil, I put it onto a smaller container. The correct way of determining the total volume of soil, because there is void spaces inside the soil particles. So what is the boundary I can give? Is there any particular boundary I can give for this particular soil to define its volume? No, right?
Yes, sir.
No, we can give. We can't give. So if I say it's a given soil, in that scenario also, the volume, the total volume can be variable. Now, again, I have said for a given soil. Okay. For a given soil, under which scenario I have not mentioned. The soil is given, but under different scenarios like addition of external force for this same soil, addition of water for this same given soil. Okay, under different scenarios, the V will change. The V will increase or decrease. But even if this particular given soil is exposed to other scenarios, the Vs will not change. So when I say for a given soil, under all the external scenarios, Vs is not changing. And you are saying is for all soils, right? Your point is for all soils.
Let me put it in a slightly better way to understood, sir.
Yes,
Can
yes,
you remove all this, sir? What you have in this slide for
yes,
temporarily?
yes, yes,
What is my question is simply, for example, I will select three soils. One is
yes.
Murram, another is
Okay,
a black cotton soil, another maybe some river sand.
okay,
When you take these three soils,
yes,
then unit weight of solids also will be different because
yes,
it's indirectly specific gravity.
yes, yes.
That's what I want to ask you, sir.
When you are taking three types of soils, yes, obviously,
Yeah, three different soils. That is what I want to ask.
three different soils, but in each specific scenario, in
Answer
each
is same.
specific,
Unit weight of solids will be same
yes,
for each soil.
yes, in each specific scenario. So that
Yeah.
is that is why you would say the term given soil. That means a particular a particular soil mass. Whenever we consider this kind of index properties, basically they are index properties, right? Whenever we are considered about the index properties, these properties are determined from various laboratory, testing and using some empirical formulas. Okay, so here this term given soil is somewhat important. We we say because a particular there needs to be a particular system within which the volume or the mass has been defined. Otherwise, we cannot go for the definitions.
Yes, sir. Question is very good because the and sometimes question one or two words will be missing, but in this question,
Yeah.
very clearly you mentioned that is for a given soil.
Okay. Thank you.
Right, sir. Thank you.
Yeah. Okay. So I'll go to the next question. I believe.
Yeah. Yes, sir. Sure, sir.
Yes. Okay. A simple question. Porosity whose void ratio is 0.5. What is the formula for porosity when void ratio is 0.5?
Actually, we have done it, sir. Similar question earlier.
E upon 1 plus E.
1 plus C. Yes. Tell me the
Mm.
answer. Yeah. Similar question we have done earlier.
0.333.
Mhm.
0.333,
Last year.
right? Yes, yes, 0.333. Yes, fine. So just componendo and dividendo, you get the previous formula. Next question. Again, formula based question. Void ratio is 1, water content 30%, specific gravity is 2.5. Now, degree of saturation.
75.
Saturation degree is moisture content into specific gravity divided by void ratio,
P.
right? So put all the values, 0.3 into 2.5 divided by 1 into 100%, 30 into 2.5, 75%. Yes. Okay.
Yes, sir.
Theoretically, the void ratio can have the following values. I guess know the answer.
Option B, sir.
Yes, can be more than
B.
or less
B.
than 1. Depending upon here, like here only, the void ratio, volume of voids by volume of soil solids, right? It can change. We take a container like this, the soil is this much, there is void, we say this is the soil volume. Okay, this is the, or we say this is the soil volume. We say this is the soil volume. Now you put the same soil in a petri dish. Okay, so volume of voids, anytime it can get more than the volume of soil solids. Okay, specifically for loose soils, non-compacted soils, obviously those will be having, there are high chances of those soils having volume of voids more than volume of soil solids. So it can be less than or more than 1. Okay, next question. A soil sample of mass 0.18 kg. Is there any doubt regarding the last question? Anyone?
No, sir, but I want to clarify if possible
Yes,
further.
yes. Please, please,
At
please.
any time, do you have any soil which has a wide ratio, something practically more than 7 or 10 or something?
7 or 10?
Bentonite, I have seen up to 5.
Okay. No, practically, I also haven't observed any soil going more than, I think 2 or 3. Okay. I
Mhm.
have also not observed.
I read, sir, in Bentonite, I have studied up to 5 or 7 also.
Okay. That might be, but
Okay.
I
Yeah.
haven't,
Okay, sir.
experienced anything like that, but practically.
Okay,
Okay.
sir. Friends.
Yeah.
Thank you.
Next question. Soil sample of mass 0.18 kg having a volume of this one. So have you solved this question?
Yes, sir. 12.5, 25.
How do you solve it?
Sir, I have defined the first densities, that is 18 into 1000, and from that relationship, we have determined the water content.
Yes. This, like this, you are telling, like this, you are saying, like first the density is 0.18 divided by this one, so it is 1800, right? So I believe rho 1 will be 1800 kg per meter cube. After addition of water, 0.2 kgs, right? 0.2 kgs, yes. So rho 2, 0.02. So yes, it will be 0.2 into, so it will be 2000.
Your presentation is not visible, sir.
Presentation is not visible.
No, sir. Fine, fine. It is okay.
Okay, right.
Yeah, it's okay, sir.
So who is saying not visible can just reload the
Sami,
window. Yes.
Samitanji, Banta. Yeah, Bansod.
Yes, 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 sir.
It is visible for me. What happens?
Something
Can you once again relog re-enter, exit and re-enter?
it is visible now, sir.
Ah,
Okay.
fine, fine. Go ahead,
Something
sir.
error was there. Yes.
Yeah, go ahead, sir.
Okay. So basically, you have to use this formula twice. Okay. Once with rho equal to rho 1 and another time rho equal to rho 2. The value of rho d will be constant, that is it is dry density, so it is 1600 kg per meter cube. Now using this, the two values will obtain as said earlier by someone, that is the first value before the addition of 0.02 kgs of water, the value of the moisture content is 12.5, and after adding the water, the value of the moisture content is 25, both in percentages. Clear?
Sir, actually, in this example,
Yes.
if anybody wants to save the time in the exams, competitive exams or something, we can
Yes.
check the answer. Initial condition is enough. No need of final.
Yes,
Initial moisture is enough.
initial condition is enough. This is just for practice sake.
Yeah,
Okay.
practicing full thing
Yeah,
is it.
practice sake. See, I have not
Yes, sir. Yes, sir.
gone through
Correct.
the scenarios. Okay, I've just taken the samples. I've thought these problems might be like good for learning the basics.
Yeah,
So
it's a good
that's
example.
that's why I've given. Yeah,
Fine, sir.
thanks. So I guess it was clear. The solution to this problem was clear. I'll go to the next problem.
Yes, sir.
Yes, a particle size distribution curve with a flat portion. What is it called?
Gap graded.
Gap braided soil. Yes. So here,
Sir,
yes,
this question at the beginning only I want to have a small interaction if you permit.
yes, yes,
I don't know time is okay for you or not.
yes, yes. You can go ahead. No worries.
Yeah, what is my the clarity required for this question is it MCQ or MS this one multiple select question?
This is a multiple choice question, MCQ. So only one option is
Mm,
correct.
the problem is in case of multiple select multiple choice question,
Yes.
gap graded soil is a subcategory of the poorly graded soil.
Yes, 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 yes.
That is
I
why
know
my
that.
question.
Yes, I know that. I think I have faced this question before also. But the thing is, um, apart from giving any solution, I was trying to be focused on the specific name of this, because
Okay,
in some questions generally what I do is I get three options and then I write none of these. Okay,
okay.
none of these options. But I know that this is also a category of poorly graded soil,
Mm,
but in some scenarios we use the term poorly graded soil only for the uniformly graded soil, right? Uniformly graded soil or poorly graded soil, these two things are interchangeably used.
mm.
Like in standard books where I have obtained these terms and this diagram also, these two terms are interchangeably used. And graded soil, you know uh, what to say, by common knowledge or by the definition, it is also
Yeah,
not,
straightforward answer it
yes,
is, sir.
straightforward answer, it is also not a good soil, obviously. So it is poorly graded soil. But this term graded soil and poorly graded soil, they are not interchangeably used, you see.
Yeah, exactly matching answer is gap graded.
Yes, so since these two terms are interchangeably used, if this was the answer,
Mm.
uniformly graded soil, then this would have been a multiple select question with both this as the answer. But since gap graded soil has has not been used as per my knowledge interchangeably with this, and that thing that I want a specific answer to this question, I have put
Yes.
this as MCQ. Okay.
And there was an extension of the same question, sir. In
In
gap graded soil,
yes,
in the question you have mentioned flat portion.
yes, flat portion, yes.
So, do you have a limitation of how many flat portions should be? It should be one or two or three or minimum
uh,
something like that?
Limitations, I don't think, in that case, like in the field condition, if you collect the soil sample, okay, if you collect the soil sample and you see that from this part till this part is absent,
Missing.
missing, so
Okay.
it will be up till here gap graded. Okay, now you can see from this part till this part is absent. So I means practically and as per my experience from field investigations and survey and all, I have not come across anything that gives any limitation, okay, as per
Okay.
my knowledge. So
Okay.
whenever there is an absence of any particle size range, then it is called as a gap graded soil, like this. Okay.
Okay.
Yeah. So the last question over here is the cube of dry clay with 5 centimeter sides. The weight is 135 gram. The same cube of soil when saturated weighs 195 gram. What is the answer to this question? So first of all, I'll try to find out the volume, that is 5 cube 125 cc, 125 cc, right? Now it was dry previously. The mass of dry soil, what was it? 135 gram. So mass of saturated soil is 195 gram. So the mass of water 60 gram. So the volume of water is how much? 60 cc, isn't it? Volume of water is 60 cc, 1 gram per cc. So what is the volume of soil solids when it is fully saturated with 60 cc of water? The volume of soil solids is total volume minus the volume of water, that is 65 cc. 65 cc. Okay. So what is specific gravity? I have found out the density over here, so I'll use rho over here. md by vs. md is 135, vs is 65. What is the answer?
1.08.
Huh? 1 point?
Which
No.
one, sir? Mass, sir? 1 second, sir.
The mass of dry soil is 135 and the volume of solids is 65. So what is the answer?
2.076.
Yes, 2.076, 2.077. Yeah, it's okay. This is the answer. Okay, I'll just repeat. First of all, the value of the volume need to be found out. The mass of the dry soil is given. The mass of saturated soil is given. Find out the mass of the water. Then convert it into the volume of water. 1 gram equal to 1 cc, like that. Then find out the mass of the, the volume of the soil solids. Once you get the volume of the soil solids, you can put the formula md by vs, mass of dry soil by volume of soil solids. Because see, density, specific gravity is what? Specific gravity G is equals to, what is the formula? Rho s by rho w, right?
Rho is that rho.
Rho w is 1. So if we find out rho s, we can get the specific gravity. Simple.
Why, sir? Answer C and D, small difference, very minute difference.
Yeah, I've tried to keep that because it's like minor change in the value, like silly mistake can give. Someone is joining right now. Okay.
Okay.
Yeah, a minor silly mistake might give this value, which is wrong, because in competitive exams you might have seen that up till uh, 3 decimal places is being asked. So if it is up till 2 decimal places, it will go to 2.08, but this will remain as 2.07. 2.07.
So,
So this is a very minor change, so it's okay, like there is no like big thing over here, but the calculation had to be specific because the values are very simple, that's why.
okay.
So okay, this specific gravity is determined. Now the next part is the
Void
void
ratio.
ratio. What is the void ratio? How do we find out the void ratio?
It's a constant, na, sir, in between anywhere.
Like what do you mean by constant?
As total volume is a constant.
Total volume is constant. No,
Yeah.
total volume,
Unchanged you have given us, sir.
unchanged volume is okay.
Yeah, total volume unchanged means indirectly void ratio is unchanged between
But what is
anywhere.
the value of void ratio?
0.9108.
I'm getting 0.923. Just a moment. The volume of voids. What is the volume of voids? I think it is 60 divided by 65. I'm getting 0.923. Please check, because the volume of void is basically the volume of water, which is 60, and the volume of solid is 65, isn't it? So it is basically 60 by 65.
That may be because of the answer which we have taken earlier, specific gravity.
Uh,
A small
no,
variation is,
no,
that is the reason I think.
no. See, I'm just using the volume of voids and the volume of solids. So how can there be a change? For example, see the mass of dry soil, the mass of saturated soil, and the volume of the dried clay that is given already. So this volume of water and the volume of the soil solids, these are obtained, right? These are obtained from these values, and the actual value is being given as 2.071. This is having no effect. I'm just calculating the value of void ratio from this volume of water and the volume of soil solids. That's it. Okay. Even if there was an influence, see, I have done this using one particular scenario. Now there is another formula like rho d equal to g gamma w by 1 plus c, g rho w by 1 plus c. So E equal to, I believe it is g by rho d
-1.
minus 1. Okay, so to find out the value of rho d, what is the value of rho d? Mass of dry soil by volume of soil solids. That is, what is the mass of dry soil? 135 by 65. What is the no? One second.
By 125, sir. Mass of the solids by
Uh,
120 road.
Mass of the solids, yes, by volume
Well,
of the total volume of the soil, yes,
it is 1
125. Right. So it is
1.08.
125. Yes, 1.08. 1.08 total volume. Yes. So 2.077 divided by 1.08 minus 1. Please do it. 2.077 divided by 1.08 minus 1.
0.923.
Yes, 0.923. So up till 3 decimal places, I'm getting the same answer using two methods. So I guess the first one is very simple because there is no need to go for this finding out the dry density. You can just put the volume of water, which is the volume of voids, divided by the volume of soil solids. You will get the value of the void ratio of the soil, which is, as means correctly said by you, is constant because there is no change in volume. Okay.
Yes, sir.
So I guess this brings us to the end of the class. I hope the session was like useful to all of you, and there was no doubt regarding any question in this session. The next session will be held on the coming Friday in the scheduled time from 6 p.m. to 8 p.m. Okay.
Sir, a small question, sir.
Yes, yes,
It's not subject question.
yes,
There is another research scholar or faculty also giving a same problem solving session, I
yes,
think.
yes.
Is these two sessions will have a different types of the questions, or similarity will be there more or less?
See, like this is like I am not discussing anything with the other scholar.
Yes,
Okay,
sir.
so I
Yeah.
don't know what questions he or she is going to give.
Okay, okay, okay.
So it might match, it might not match. It is
Yeah,
basically,
the reason why I'm asking is
yes,
as a audience, we
yes.
have to attend both, or it is the same. That is my question.
Uh,
If it is the same session you are repeating it, then no need of audience. We have to waste
See, I
two.
cannot tell about the other scholar. I haven't seen any of his lecture, but I generally
Okay, sir.
see others people who give lectures these problem solving scenarios. They
Mhm.
basically, they limit their sessions to only numericals. But I try to combine a bit of multiple choice questions, multiple select questions, true, false, and numericals to keep the interaction live. Because if I give any problem and I like go on solving it, it's not it might not become so much interactive. Okay, so
Okay.
that thing I can say I've done this session for the
Yeah.
past 2 years. I think this is the fourth session I'm taking, so that I can say. But currently for this course, what the other scholar is taking, that I have no idea.
Yeah,
So
the questions are different, sir. I attended both of them. The
okay,
questions are completely different. It's
okay,
good
okay,
for us to attend both.
then it's good
That's
for
my
you.
message for the audience also.
Okay, then it's good for you. Good to know.
And another point for you, sir.
Yes, yes,
In another course, I don't want to mention the course here. I am taking a different courses here.
yes.
After problem solving session is recorded, when you put this one in, when you upload this one,
Yes.
what happens is in one of the session in another subject, audio of the faculty is not coming.
Okay.
For
So
example, you are talking right till now
yeah, yeah.
live. During a
So
problem solving session, it is okay, but when you upload it,
mhm.
only audience voice is coming, but your voice is not at all coming.
Okay, see, I have also faced this issue once, like in the last semester. There are
Hmm.
many technicalities involved while taking these sessions, right? First of
Okay.
all, like I'm using a microphone. Previously, I used to use a Bluetooth headset that might get disconnected anytime without
Hmm.
my knowledge. Okay, I'm using right now. I'm using OBS screen recorder. So I have told you now that I cannot go full screen because I have to toggle between the
Yes,
OBS
sir. Yes,
screen
sir. I
recorder and
understood.
all those things. So
Understood.
anything might go wrong.
Hmm.
See, online classes are good because you can sit at your home and attend the classes. But for
Hmm.
the person who is teaching, there are so many technicalities involved that if one of the thing goes wrong, then it might be a mess. So I think I have faced these kind of issues, and I cannot say that there was a wrongdoing on the part of the instructor, because something might have gone wrong and the audio might not have got recorded very well in the OBS recorder, because OBS studio that I use and many people use, it falters a lot. It like falters a lot, so
Hmm.
it might be a glitch.
Okay. Okay. Okay.
Yes.
Right, sir.
Yeah.
Thank you. Thank you very
Okay,
much.
thank you for attending the class.
Thank you, sir.
Yeah.
Thank you very much.
Bye.